Hello and welcome to this video on arithmetic sequences and series, a nice easy C1 topic with some difficult notation to make sure you know. So we've got a sequence like this one. This sequence we can see that to get from 5 to 9 we add 4. To get from 9 to 13 we add 4. To get from 13 to 17 we add 4. ... And finally we add 4 to get to 85. So the first thing we can write down are important notation. The first term we call A, and in this case A is 5. The other important bit of notation we need is common difference, D, and in this case the common difference plus 4 is 4. So that's just the amount that it goes up by each time. So plus D, plus D, plus D. So we can write down that our first term is A, and then our second term will... So our second term is A plus the common difference, which is D. Then the third term is A plus D again. So we've got A plus 2D. And then if we continue for a bit, we can generalize this, saying that the nth term will be A plus n take 1 times D. Now that's an important formula, so make sure you've got that written down. Our next step is to work out how many terms we have. So if we know that 85 is the last term, we can say that n is the number of terms. So if 85 is the nth term, then using our formula we've got written here, we can write 85 equals A plus n take 1 D, which in this case will be A, we said before, was 5, plus n take 1 times D, which is 4. So 80 is n take 1 times 4. Therefore n take 1 equals 20. Therefore n equals 21. So a question will usually be asking us to find the sum of these terms. So we call this S. So let's write this out. So here I've written out most of the terms, and I got this 81, because I knew 85 was the last term, and I just took away the common difference of 4, minus 4 to get that term. Okay, so is everyone okay with the fact that this is the same as this? Okay, so we've just written these in the opposite order, but they're exactly the same. Now we want to think about adding these together. Okay, so if we do 85 plus 5, okay, so here we're going to get 2s. 85 plus 5 is 90, and 81 plus 9 is 90. And okay, if we go further up here, what have we got? 81 plus 9, so 90. And here we have 85 plus 5, which is 90. And believe it or not, this is not a coincidence. So because we know how many terms we have 21 terms, so we have 90 21 times. So we've got 2s is 21 times 5 plus 5 plus 20 times 4. So 5, this is the first term, and this is the last term. So we've got 2s is 21 times first plus last, or n times the first term plus the last term. So then by dividing by 2 on both sides of the equation, we get these two formulae which we use both of. So write these down in your survival kit. So people say maths is a universal language, so we're going to practice translating things like this, the third term is 25, into lovely maths. So when we see the third term is 25, that is not what we write. What we write is, we use our formula and we say a plus 2d is 25. The same applies if we see something like this. We don't write the sum of n terms is 100. We write this formula and set that equal to 100. This is how we're going to answer questions, not with silly words like this. Now, you need to pause the video and practice these translation questions yourself. And so unpause the video in a minute. Okay, so now we can go through the problems if you've done them. So for the first one, we've got the fifth term is 11. And so when we translate that into maths, we get a plus 4d is 11. The next question says the eighth term is 7, so we've got a plus 7d equals 7. This one says the sum of the first 8 terms is 12, so we use this formula. However, it's actually told us n, so we can write this as this, and then we can simplify a bit to this. So same kind of method for the next one, so we're using this formula, substituting in, we get this, and we can simplify that to a 9 instead of 18 over 2. Okay, the 12th term is minus 7. We write like this, and then the sum of the first 9 terms is 15, using this formula again. We get this. Then the 17th term is 91. We write a plus 16d is 91. Sum of the first 52 terms is 500. We get this, and this is the same as 26. Here. Okay, 11th term is 9. A plus 10d is 9. And the sum of the first 6 terms is minus 20, is this formula again. And we can write 6 over 3, we know that is 2. Now finally we're going to prove the formula for the sum. So this is worth about half a grade in the exam. It's easy marks, all you need to do is learn these 5 lines off by heart. So first let's write the sum. So in this case we're not specifying A or D, we're just doing it for any A and D, and we get this from using the formula. So that will be the nth term, that's the one before. We've taken away, all we've done here is taken away a D, and so as we did before we can write that in reverse and it's exactly the same. S equals, now all we need to do is add these together, so we'll get 2S. So if we add these two together, we get 2a plus n take 1d. If we add these two together, we get 2a plus n take 1d. And dot dot dot. If we add these together, we get the same. If we add these together, we get the same, just like we did before. So how many of these do we have? We have this n times, because there are n terms, and then so we can write 2s equals n times 2a plus n take 1d, and then we can divide both sides by 2 to get s equals n over 2 times 2a plus n take 1d, which is the formula. So we've proved it.